Good afternoon, everyone. Thanks for coming. Really excited to be here. I love doing this presentation. This is maybe the third or fourth time I've done this one in particular. Maybe you've seen it before, actually. But we're going to cover three main points in the next hour. Normally this is an hour and a half, by the way, so this is going to be a little crunched. We'll see what we can do. I'll still try to take as many questions as I can. But three main points I want to cover. First of all, what are the different program types you can use with SOLIDWORKS API if you're trying to do your own custom development? And then second, what are the languages available to use in order to write those programs? And then lastly, what are some recommendations for your specific cases? And for those of you who don't know, my name is Keith Rice. I'm the technical director at CAD-Sharp LLC. And as far as I know, we're the only company on earth that is 100% exclusively dedicated to SOLIDWORKS API and PDM API development. That's all we do. Custom development, don't even sell products. We just do bespoke development, to spec, whatever you want. And we also do training, and we have an online course as well that many of you might be familiar with. That has a lot of free content. So yeah, hopefully this will inspire you, get the gears turning in your head about how you can start automating your own processes. And if you want, stop by our booth as well. We're at 118 if you want to talk more. There's quite a few people here, and if you don't get your questions answered here, then you're more than welcome to stop by and talk to us further. So first of all, let's do a poll. How many people have done any sort of SOLIDWORKS API work at all? So about half of you, and then I guess I can assume that the rest are either interested in getting into it, or maybe you're considering hiring somebody to do development, maybe internally, maybe externally. There's a lot of companies that have their own development teams, even depending on the size of the project. So how many of you have written a VBA macro? Okay, about half. That's starting off lower level. How about a standalone? Ooh, a lot less. Okay, how about an add-in? All right, also much less. So add-ins and standalones, as we're going to find out, are much more complicated than macros. That's why it's more common to see people who have worked with macros, and hopefully this presentation will give you a good idea of the differences between all three. So again, there's macro, add-in, and standalone. I'm going to show you in a moment which programs can be used with which languages and when you should use them. But keep in mind those three program types. Those are the only three types of programs you can create. A macro is sometimes also called a script. Scripts aren't technically compiled. SOLIDWORKS macros technically are, but you can still think of it in the same terms if you're familiar with scripting in other software. And then the languages available for using SOLIDWORKS API are VBA, VB.NET, C#, and C++. Officially, you can actually use any language that supports COM. I've seen people use the SOLIDWORKS API with Python, with Java. I think those are the two main ones I've seen come up on the forums, but 99% of the time, people are doing development in one of these four languages. And I'll even say that C++ is not used real often, unless for some reason you have a lot of experience with C++, feel really comfortable with it. If you want a C-style language that has all the curly brackets and all that good syntax, then you're probably just going to go with C#. So the first three are definitely the most common. So here's a great chart with all of your options, because some program types only work with certain languages. So you have the macro, which is, as we know, the simplest and easiest way to get into SOLIDWORKS API programming. It's not, in my opinion, the best way to do API programming, but it is nevertheless the easiest to get into. And you can use VBA. That's what's most commonly used. And if you go on the forums or on a website like ours, cadsharp.com, or you just Google for examples, more often than not, you're going to see examples in VBA. So even if you intend on being a .NET developer, and by the way, C# is also a .NET language, even though it's not called C#.NET. C# and VB.NET are both .NET languages. Even if you intend to use one of those languages and be a .NET developer, you should still learn some VBA simply because there's so much material out there that's in VBA. So many examples, help files, etc. You know, most of the time when you see an example in the SOLIDWORKS API help, they're at least going to have an example in VBA and then maybe in .NET and C++. So always great to be familiar with that language. And then you can create .NET macros, and those are also called VSTA macros. Has anyone ever created one of those by chance?
Just by accident.
Okay, by accident. One of you, like officially, you're willing to say, yes, I've created it. So that was kind of a technology that Microsoft came up with to allow you to use .NET as a replacement for VBA. So VBA is a Microsoft language as well. You can use it in Office products, for example. If you've ever written an Excel macro, you would have used VBA. And you can use this other technology called VSTA with .NET, but not many people do it. And there's two reasons for that. First reason is that the DLLs that get produced can be unstable. I don't know exactly why, but I've not had a lot of luck with them. Number two, if you're going to go through all the effort to create a VSTA macro, in my opinion, you might as well just create a standalone anyway, because standalones are very easy to set up. So what ends up happening is if you boil all these options down, really, at least in what we develop at CAD Sharp for customers, we tend to end up either developing a VBA macro if the customer wants a macro, or if they want an add-in or a standalone, we're just going to use one of those .NET languages, and we'll leave that up to developer preference. Pretty much everyone at CAD Sharp knows VB.NET and C Sharp. Sometimes the customer will specify which language they want us to work with because maybe they want to take the project internally after we've gotten off the ground. But if they don't care, then we usually default to C Sharp. C Sharp is a little bit more popular, so if you're just looking for examples of how to do general C Sharp programming, there's going to be more of those than VB.NET. And then VBA can't be used with add-ins and standalones. You could use VB6 back in the day. Some people still use it, but I would not recommend that anymore. I'd recommend using .NET. And then C++, as I mentioned, really doesn't bring a lot of advantages over C Sharp if you're just looking for that type of syntax, so I don't see that being used a lot. So even though there's 12 options, really only about 5 of those actually end up getting used most of the time. So what do these different languages and program combinations affect? It's going to affect, or the program type is going to affect things like, number one, integration and flexibility. How integrated do you want your software to be with SOLIDWORKS? Do you want your users to have this this native SOLIDWORKS feel as they're using your program? Do you want to be using property manager pages and task panes and menu drop-downs and the command manager? Do you want it to feel like it's part of the software? Well, if you were going to go that route, you would definitely want a macro or an add-in. But what if you want a piece of software that is independent of SOLIDWORKS, that can actually control SOLIDWORKS and control other software? And if SOLIDWORKS crashed, this program could actually restart SOLIDWORKS and pick up where it left off. In that case, you need more flexibility, and that's where the standalone executable is going to come in. And as we'll see in a moment, a standalone is an EXE, and an add-in is a DLL. A DLL runs inside another executable, in this case, sldworks.exe. Then you have to factor in ease of development. Based on my budget or time, is this a project that I'm only going to be able to work on during my lunches for the next month? Well, if you're in that situation, I can tell you you're not going to get real far with an add-in. You might want to just stick with a macro. But if you have the time to develop something more robust, then you definitely want to go the way of .NET, in my opinion, and do a .NET standalone or add-in, depending on your needs. And then likewise, distribution, administration, macros, which are SWP, and let me actually show you instead of just talking about this. The macro, SOLIDWORKS macro has an extension .swp. You're probably familiar with that. Well, if you write a macro, it's very easy to pass that around your company. You can even store that on a network drive, tell everybody to point to it, and then it's really easy to administer because whenever you update the macro, you can literally just replace that macro file, you're good to go. With an add-in and standalone, it's more complicated. In particular, with an add-in, your add-in has to be registered on each user's local machine, so rolling out updates for that is going to be significantly more complicated than if you work with a macro. Yet a macro can be understood as a simplified version of an add-in, since it also runs within SOLIDWORKS. And I'm going to show you some examples of all these in just a moment. And then there's also the consideration of performance. Add-ins and macros are going to run faster because they're running inside the SOLIDWORKS process. There's no process boundary like with an executable. So that's a downside to standalones. And depending on what you're doing, it can actually significantly affect performance. We've written some software that, for example, will generate drawings for very, very large assemblies. And whether we run it as an add-in or a standalone, it could be the difference between 5 minutes or 30 minutes, something like that. So this can make a big difference on performance. And then you also note that I did not include a section called functionality, and this is a question that comes up sometimes. Are there certain API calls that only work in certain program types or certain languages? And yes, there are on rare occasion, but for the most part, any API call you need to use is going to work the same in any of the programs. Nothing really fundamentally changes with your usage of the SOLIDWORKS API. Now with a standalone, you might choose to run your standalone invisibly, which will increase performance because you're not getting the GPU involved at all. In that case, you'd use an API call called isldworks.visible, and then you'd set that to true or false. Obviously, you would never use that in an add-in because you probably created that for the end user to use. Why would they want it to be invisible? So even though that could be used in an add-in, you're typically only ever going to use it in a standalone. So in that sense, you'll see certain API calls used in certain program types more than others, but that doesn't mean they can't be used in any program type. And then the language, likewise, affects things like how easy it will be to develop. So if you're brand new to programming, it might be a bit much to jump into C# right away. VBA might be a little bit easier since there's so many more examples. On the other hand, if security is a big concern, if you don't want people tampering with your code, if you're even going to try to create a product to sell, well, VBA macros are a really bad way to go because even though they can be password protected, you can crack them. Actually, I have a blog post on how to crack them in case you lose your password or something like that. So not very secure. On the other hand, .NET, you're going to be working with a DLL, which is compiled. So if somebody wants to crack your code in that case, they're going to have to decompile your DLL first. Well, that's not actually that hard to do. There's a lot of programs out there that will let you decompile .NET DLLs. But on top of that, what people will do is obfuscate their code, which means that the variable names, the class names, the method names, they'll be scrambled, or just really weird characters will be inserted so that it's hard to decipher and understand what was going on. Obviously, comments are stripped out. And so the program's still going to function the same. The code is, in terms of functionality, remains exactly the same, but just reading it becomes a nightmare. Of course, even that, somebody with enough time, they could figure it out. My personal opinion when it comes to security in software like this is that less security is better, because when you're doing SOLIDWORKS API programming, you already have the benefit of what is called security by obscurity, and that's the simple fact that not a lot of people know how to do this programming in the first place. So the reality is I could take the most valuable program I've ever written, plop it out on GitHub for the world to see, and are any of my customers going to somehow end up losing money? Am I going to end up losing money from that? Not really, because most people don't even understand how it works. Some of my colleagues don't even understand how my code works. I don't even understand how some of my code works like 6 months later. Some of you have probably been in the same boat where you write something and then look at it a year later and you're like, what on earth was I thinking? That makes no sense. That's pretty common with programming. So Don't get a big head and think that your code is so amazing and great that people are going to want it so badly. I prefer to avoid too much of that because you end up tripping over it on your own more than it actually helps you. And then lastly, there's very slight performance advantages and disadvantages to the different languages, but we're not really going to cover that. For all intents and purposes, the languages are pretty similar. So let's take a look at some of these. Let's open up SolidWorks first and look at the simplest form of program that I talked about, which is the VBA macro. And as I mentioned, the VBA macro has the SWP extension, and you're probably familiar with tools, macro, and there's your little macro options. I also have my toolbar open here, and I'm going to actually edit the macro so you can look at the code briefly. So what this program is that I've developed in each of these languages is nothing more than a little form that'll pop up and ask you the height, length, and depth of a cube or a rectangle or block, whatever. And it's going to create that from a new part template. Pretty simple. But we're going to see what that looks like in the different program types and different languages. So I am a firm believer in the programming principle called separation of concerns, which means that I like to keep my code separated in terms of function. So the way you can see that in this program is that I have my entry-level module, which I called immain. All this does is launch the user form. This is the entry point for my code, and then that's going to launch this, which I've set up here, height, length, depth. And when the values are entered and create block is clicked, it's going to do some calculations to convert, I think, those values input into meters, because the SolidWorks API thinks of everything in terms of meters, kilograms, and seconds. So even if they input it in, say, millimeters, it needs to be converted. That's why I'm dividing by 1,000. And so we're going to handle some form logic in here, and then we're going to call our module or our class that actually has the SolidWorks API calls. So you can see how I split it up into basically different concerns. One part of the program is concerned with just launching everything. Another part is concerned with just the user form, the UI. And by the way, this is not, don't consider this like a professionally written final version of a program. I've not done a lot of error handling here, so just be aware of that if you decide to use this as a template for your own projects. And so then the last module I mentioned is the one that actually does the processing. It actually makes the SolidWorks API calls, so you can see that we're passing in those 3 values that we obtained from the user, and we're going to get the path to the part template. And I think this is the only error handling in the program, just making sure that that template exists. And then we're going to create a new document. We're going to find the XZ plane, which is the top plane. And a lot of people, the way they would have handled that is by using a API call called iModel.extension select by ID2. And they would just write in the name top plane or something. It's a little bit dangerous when you make assumptions like that in your code, because what if you send your program to another user whose localization is in English and they have a different name for their top plane or something? Your program could possibly fail. So usually there's kind of like an inversion principle with assumptions versus code length. I decided to remove that assumption, assuming I knew the name, and I have longer code, but my code is more stable. So what I'm actually doing here is traversing through the feature tree until I start finding features called ref planes. That's the type according to the SolidWorks API. And you might not have known this, but the reference planes in SolidWorks are always the same, in the same order. It's XY and then ZY and then ZX, I think maybe. Anyway, they always follow the exact same order, so I'm waiting until I get to the XZ plane, then I'm selecting it, then I go on to insert a sketch, create a rectangle using the sketch manager, and then use the feature manager to create that extrude base. So let's see what this looks like. Let's go back here, run this. Let's enter in some random values. So VBA macro might be something you're already familiar with. And that is, like I said, the simplest way, in my opinion, to use SOLIDWORKS API, not necessarily the best way. I find it very tedious to work with VBA. I would much prefer to be in .NET these days. In fact, I'll pretty much argue with the customer on the phone till I'm blue in the face, trying to persuade them to let us do an add-in and not a VBA macro if they're insisting on it. Because VBA is just not that fun to work with. It's based on Visual Basic 6.0, which was last updated in like 1996 or something. So we're kind of using an ancient technology. Nevertheless, VBA is not going away. I'll note that. So if you do have a lot of legacy code that's in VBA, or you're thinking about getting into SOLIDWORKS API but want to keep it simple, go ahead and use VBA. There's nothing wrong with it. It's not going away. Microsoft's going to keep supporting it at very least, because think of all the Excel macros that are out there that they have to keep supporting. And next up, I'm going to show you the add-in. So I'm going from macro to add-in just because add-ins are similar to macros, but this doesn't reflect complexity. Really, in terms of complexity, it goes macro, then standalone, then add-in. Add-ins are far more complicated to set up than standalones. Nevertheless, since it's similar to a macro, I'm going to show it to you next. So the way I've integrated this add-in with SOLIDWORKS is through a drop-down. Just like that. This is, in my opinion, the simplest way to create an add-in user interface. You can also create buttons in the command manager. You can create toolbar buttons. You can create something in the task pane over here. Another option I've seen quite a few times that I think is really cool is people will override commands. Like I had a customer who wanted to use their own custom material dialog that would let the user quickly search through their own custom material database. So when the user would right-click on Edit Materials, it would cancel the opening up of the default dialog and it would open up this new one that I created for them. So basically overriding an existing command. So lots of different ways you can integrate add-ins, but this is the simplest. Just have a drop-down menu here. I called it My Tools, Create Block, and again, we're in .NET now, so that's why the user form looks a little bit different. So there you go. Of course, it should function the same. Now the add-in, if we go up here, go down to other add-ins. This is always where your add-ins are going to be located, or any third-party add-in. You can see that I called it My Tools. My Tools by CAD Sharp LLC. That's the description that's in the registry keys. And then you can actually see the path to the DLL on the hard drive. So macro is an SWP, like I mentioned. And an add-in is going to be a DLL, which stands for Dynamic Link Library. Both of those, though, have to run in the sldworks.exe process. You cannot just go out to your hard drive and double-click on an SWP or double-click on a DLL and it'll run your program. You have to run it within another executable. Any questions up to this point before I show the standalone? All right. We are moving a little fast, but don't hesitate to stop me. I love answering questions. I want to help you understand this. So what I'm going to do for the standalone is I'm actually going to go into my binary folder, bin, and this is where the program was compiled to. This is also where the DLL for the add-in was compiled to, but again, we run it through SOLIDWORKS. That's why I just opened up SOLIDWORKS, but this isn't executable. It's not running within SOLIDWORKS. It's its own separate program. And let's actually do this. Let's run it from within, Visual Studio. So when I opened the VBA macro earlier, we were working in an IDE, an integrated development environment called the VB Editor. And again, that's the same editor that you would use to do Excel macros and whatnot, and it's usually attached to a particular program. When you create, that's how you create VBA macros. When you create a .NET add-in or a .NET standalone, you're going to be in Visual Studio. Much nicer environment to work in, much faster, even though the languages you could say are more complicated, because the IDE has so many more features to make your life easier, it still ends up being way easier and way faster to write software and use Visual Studio. And it's one of those situations where, you know, you might be using VBA for a while, get comfortable with it, like it, be afraid to take the next step to Visual Studio. But, you know, once you try it, it'll be really hard for you to go back. It's really that much more enjoyable. So this is the code. User form, again, is going to look similar. Logic is going to look pretty similar. And this code, of course, is basically copied directly from the macro. There are a little bit of differences between VBA and VB.NET, not many though. So if you're really comfortable with VBA, you know, maybe VB.NET is the next step you should take because the syntax is similar, whereas C# might be a little trickier to read. But there is one difference. Since we're not in a macro or an add-in, which is already connected to SolidWorks, we need to come up with our own way to connect to SolidWorks, and that's what we've done right here. If we go back to the user form, not only am I calling the function that creates the block, but first I'm connecting to SolidWorks. And I'm doing that using a .NET function called, belongs to the activator class called createInstance, and you pass in the program ID, and it's actually going to return SolidWorks invisible by default, so we need to make it visible. And I actually mentioned this API call earlier, isldworks.visible. That is what controls the visibility of the SolidWorks software. So if I run this, let's see if it creates SolidWorks. Took a little bit longer to get going there, unlike a VBA macro, which was just instant. That's because when you're writing .NET software, if you make a change, it's always going to have to recompile. So it'll recreate that executable or that DLL, whatever, put it in that binary file. Click create block, and we got an error. Sorry, guys. Guess I tried. No, does anyone want to tell me why they think that error is occurring? I'm not in SolidWorks. Nope. This is a bit of a tricky one. Look really closely here. Okay, somebody said it, 25. Wrong version. This is a danger you can have when using .NET standalones. If you hard code in a specific version, and basically I'm using, you know, this program that I've been using for a few years now. So last time I did this, it was SolidWorks 2017. I thought I'd leave this in here just to show you. 25, that actually corresponds to 2017. That's the major version. If you ever want to convert from the year to the major version, all you have to do is take the year and subtract 1992. So this comes out to, 2017 would come out to 25. So what we could do is we could put in 27, which would be 2019, which is what's on this computer. Or we can actually just remove that entirely, and it should grab, I forget if it's the version that was last opened on the computer or last installed on the computer. I think last opened. But this will work with multiple versions, and it will grab one of them. So let's try this now. And that activator create instance, it will create a new instance of SolidWorks, and it will actually connect to an existing instance. So either way, if you want to have it open already or you want to have it closed, it should work either way. So let's actually try that. Let's close out of this. And, oh, here we go. Let's see if it'll connect again. Yeah, so it connected to the existing instance. So that was the difference between a macro, an add-in, and a standalone. Any questions now before we get a little deeper, a little more complicated?
You can show code on the add-in, I'm curious.
Oh yeah, I can do that real quick. Absolutely.
How do you actually get it to make the buttons and menus and things like that?
So open Visual Studio, and I'll just show you right now, if we go into the project, the bin folder, which stands for binary, the debug configuration, notice it's compiling to a DLL, not an executable. But every time you change your code, it will recompile. So let's open this, and I'm going to start backwards in the add-in. The SolidWorks class, completely identical, except we don't have that create SolidWorks function. We don't need that because we're going to get the pointer to the software ISLDworks interface when we connect to the software, and I'll show you that in a second. And then likewise, this form is basically identical. Did a little more error handling there, but otherwise pretty much the same. So here's the big difference though. This main, this was not in the standalone. In that standalone I showed you, which was a Windows form application, as soon as we ran it, it opened a Windows form. This is not going to open a Windows form right away. Instead, what's going to happen is this function is going to run as soon as SolidWorks attempts to load the add-in. And this is basically a handshake with SolidWorks, saying, I see you, you see me, we can talk to one another. So this function, connect SW, and this other function, disconnect from SW, these are implemented as part of the ISLDworks interface, which is part of one of the primary interop assemblies that you need in order to use add-ins. And basically, every add-in has to have these two functions. These two functions run when you load SolidWorks or whenever you go into the Tools add-in dialog and click that little checkbox to activate your add-in. This is going to run. And then likewise, when you uncheck that checkbox or you close out of SolidWorks, this is going to run. Those two functions always have to be present in your add-in. That's what makes an add-in, as well as also having what's called a GUID, a globally unique identifier, and this tag that is saying that our DLL is COM visible. It can be seen by COM, and it can also be seen by SolidWorks. So part of what makes add-ins more complicated isn't just the extra code, it's also that you have to worry about registration. Your add-in has to be registered in two places. It has to be registered with COM, and then it also has to be registered with SolidWorks. Two different sets of keys, and if either of those sets of keys are messed up, SolidWorks isn't going to see your add-in, and you're scratching your head and thinking, man, maybe I should have just stuck with VBA because this was so simple. So the handshake occurs. This I'm not going to get into, but this is some extra code we use to make developers use to make life easier when they're registering SolidWorks during development. Now down here is the user interface. So we have to, unlike with a macro shortcut, which you can just set up through the customize menu, with an add-in, if you want something to be visible via UI, you have to specify it. Nothing is going to happen by default. So in our case, just to make that simple little drop down, we had to add all of this code. We had to set up our add-in callbacks. We had to create a menu, which I called My Tools. Then we had to create submenu items. That's going to happen when the handshake occurs. And then when the disconnect occurs, we need to make sure that we remove the UI. Otherwise, it's going to stay there and it's just not going to do anything, which is going to be annoying and awkward for your users. And then we have to set up this callback function, which basically is telling SolidWorks, when you see somebody clicking that menu item, run this particular command. And that's when we get into the action in the rest of our add-in. So a lot of extra setup work. And go ahead.
Has an exception that the remove never runs and is stuck there, right?
Depends on, if the menu already got created, that can happen. I mean, it's pretty easy to undo it though. It's not like your SolidWorks installation is going to be a disaster with all kinds of extra vestigial menus and whatnot. You can usually get it cleaned up, but yeah, theoretically that could be the case. Obviously, I mean, this top level class, this entry class, what you're going to do is you're going to get basically a template that's down pat, it's working solid, and you're just going to keep using that over and over again. And then in the rest of your code, like for example, this solidworks.vb, generally what I do is I have like an entry function there that says like begin processing or something like that, that calls the rest of the functions. And in that top level function, I'll have a try catch block that catches exceptions that can happen in the code. Certainly, yeah, good programming practice is that whenever an exception occurs, you don't just want it thrown in your user's face with a bunch of weird .NET, language or stack traces or whatever you have in there. You want it handled nicely. Something like an error occurred, please get the log file here and send it to tech support. Something like that. Okay, so that was a look at the code. Any more questions before I go on discussing this? Some of the differences, some of the advantages and disadvantages? Okay. I want to go back to standalones briefly. This is not something I talked a lot about in previous classes, but it keeps coming up in my work, and it's a very interesting problem. Actually, a couple things here. First of all, the user form I showed you with the standalone, and like I said, it compiles down to an executable. We're talking about the executable again, which I should be able to run just by double-clicking on this. That user form's nice, but what if you have a situation where maybe you're an admin and you want to run your program kind of more discreetly, maybe on a server, you want it controlled by another program. You can also set this up so it just runs through the command line. And so I'm going to show you what a command line standalone would look like. Let's go ahead and keep SolidWorks open just to keep it simple. And come back here. Now this is a console application. So if I open up the solution, we're not going to see a form. There's basically no user interface for this. Instead, what we're going to see is a main sub, and then we're going to be using system.environment.get command line args. So we're going to let the user or the administrator, whatever, pass in arguments. It could be manually through the command prompt. It could be through a batch file. It could be through some other script. But it's going to give you the flexibility to run this program without requiring a user interface. So obviously you can imagine this is one of the approaches of choice when you're trying to create a program that will run on a server and maybe doesn't need a user interface. Here's what that is going to look like. Let me go in here to the bin folder, an executable, and just to prove it, if I double click on that, notice it just pops up, disappears right away. It's because I didn't pass in any arguments and I didn't tell the console window to stay open. So instead, let's bring up the command prompt and let's drag this in here. And the way this works is I only need to pass in 3 arguments. I just need to pass in those 3 numbers like we talked, or like we saw earlier, the height, length, and depth. And now, if I click that, it should run it just fine. So you have that option to you as well if you're doing a standalone. You don't have to have a user interface. You can use the command line. Now let's take it to the next level. Right now we're using that call activator.createInstance in order to create SolidWorks, right? Very simple to use. In fact, if I show you the code once more, instead of opening up Visual Studio, I'm just going to open it here. Right there, that was it, activator.createInstance. Pretty simple to use. Just pass in the type there. There's some disadvantages to this approach. Even though it's very simple to use, there's some really big disadvantages. I'll give two of them. First of all, whenever you create SolidWorks using this method, it's not going to have most add-ins loaded. And if your software interacts with other add-ins, let's say PhotoView 360, maybe some toolbox, if that's not loaded in there, then you're going to have to add in extra code to do that within your program. The bigger disadvantage to create instance is it will never open up more than one version of SolidWorks. Well, unless you specify different versions in that parameter. But even then, let's just say on this computer, which only has 2019, you can run this 1,000 times and it's always going to return the pointer to whatever instance is currently open. Sometimes if you're trying to do some really major bulk processing, what you would like is for multiple instances of your program to be running multiple instances of SolidWorks, or maybe your program, just one instance, to be running multiple instances of SolidWorks. That's a much more complicated problem. You can solve that using standalones, however, but what you have to do is basically mimic manually opening SolidWorks. You basically just launch the executable, and then you have to find the pointer through what's called the running object table, and then you can control that individual instance. If you're interested in going that route, we do have developer libraries that will let you do that. It's pretty complicated to execute, but that's a very powerful solution if you have a piece of software that you want to run on a server and you want to spin up multiple instances of SolidWorks and maybe create multiple drawings simultaneously. That is possible, but you can't do it using this simple method that I showed you here. All right, so we'll just go over a few other general points. Again, if you have any questions, feel free to ask me, as we only have 15 more minutes, so don't hesitate or come and talk to me afterward. But again, we already talked about this. Macros and add-ins run in the SLDWorks process. They have more options in terms of a user interface. They attach to existing SolidWorks sessions. Standalones can do that. But then a macro and add-in, of course, can't open a new session of SolidWorks. You have to already be in SolidWorks. So my opinion is that if you aren't going to get really serious, I'm going to just start talking more about recommendations now since we don't have a lot of time. If you view your SolidWorks API experience as being something like, I'm just going to do this occasionally, maybe an hour or two here or there, maybe no more than 5 to 10 hours a month or something like that, I would say, and the program you're going to use is maybe just for yourself, maybe just for you and a colleague, you're probably best off just sticking with VBA macros. That's probably simplest. If you are feeling more serious though, or you want something that's going to be spread wide across the company, I would definitely recommend using .NET, but you need to make it very clear to your management that it's going to be a time investment. And if you're not going to invest the time, you're not going to have a good piece of software. So that's when you want to talk to, a third-party source, outsiders, about writing it for you. But, summarized, macros, yeah, they're easy to set up, they're easy to debug. Add-ins are not that easy to set up, again, because you have to do registration. They're not as easy to debug either, because every time you make a change to the code, you have to shut down SolidWorks, edit the code, restart SolidWorks, get back to wherever you were in the program. There are some ways around that. You can create what are called like hybrids, that basically where you have an add-in written, but you've made the functions in it public so they can be accessed through a standalone, and then you can create a standalone that's basically looking in the add-in code, using that code, but is still able to connect to the existing SolidWorks instance every time. That can greatly speed up debugging, but again, it's a lot of extra setup. If you're looking for just pure simplicity, you probably want to stick with a macro. Let's see, let's move on to the next slide. Like I said, macros pretty easy to distribute and administrate because there's no installation. You can even run it off the network. If you have a program that you always want to be running in the background, you can do that with a macro, but I would recommend you do it with an add-in instead. Of course, even then the user can turn the add-in off, but sometimes companies will have something where, like, every time the user goes to save a document, it will automatically save it out as a PDF to some engineering folder as well. That way, the engineer will never forget to do that. You're basically going to be listening for certain events in that program, and you're going to want a macro or an add-in in that case, but more robust option would be the add-in. Good for commercial distribution. You definitely want to go the .NET route. Can't see any good reason to publicly sell macros in any serious sense. And then macro features we're not going to get into, so we don't have time, but there are some pros and cons there as well. Let's see. So performance, not significant enough that I'm going to spend a lot of time talking about that. Languages, I think I've said the most important points. If you want to keep it simple, just stick with VBA. But again, it's kind of weird because, like, if I wanted to sit down and write a really simple program that was going to be less than, say, 30 lines of code, yeah, I could write it faster in VBA. But let's say I wanted to write a program that was going to be 1,000 lines of code or do quite a bit. VBA is a simpler language, so I could write it faster, right? No, just because the IDE is so annoying and so, archaic, that Visual Studio is going to give me a lot of tools to make my work faster. So again, if you see yourself spending quite a few hours of time programming each week, I would definitely recommend getting into .NET. We already talked about security. I mentioned that VBA macros are the least secure, and then performance is not real significant, but technically .NET is a tiny bit slower because it has to cross that boundary between .NET and COM. And then, let's see. All right, so recommendations. Again, let me know if you have questions. We have 10 minutes left. So again, I would recommend learning the SOLIDWORKS API with VBA. Even if you end up using .NET mostly, you're always going to want to know some VBA because so many examples are in VBA, and also because VBA macros can be a little sandbox for you. Let's say I'm writing a C# add-in. I'm like really in the thick of it. And I get to this point where I know I need to use this particular API call, but I'm not really certain how the arguments work. I'd kind of like to create a little sandbox test environment to test that API call out. Well, VBA is perfect for that. So even as a .NET developer, somebody who doesn't really enjoy working in VBA, I do enjoy working in it if I just need to test something really quickly because it is faster. A VBA macro is still a nice little sandbox environment, and once I get it working in that VBA macro, I can maybe copy my code over to VB.NET and then C#, which, by the way, let me talk briefly about this real quick. Let me grab, say, all this code. So I mentioned that VB.NET and C# are both .NET languages. They can be converted to one another very easily because they both use the exact same functions and calls in .NET. It's just different syntax. That's it. So there's actually lots of free tools out there that let you convert between one or the other. So if you're thinking, man, I would really like to learn C# one day, but I'm not certain I'm ready for that just yet, that's fine. You can go from VBA to VB.NET, and then once you're ready to get into C#, there's tools out there that can help you convert back and forth. Because both those languages, both VB.NET and C#, they compile down to the same lower level language that's used in .NET, which is called the Microsoft Intermediate Language. So just to prove this,
Have you seen one for 6 to .NET?
For which language?
VB6 to .NET?
Actually, if you paste VB6 code in a VB.NET program in Visual Studio, it will do a lot of conversion for you. It will remove certain keywords that aren't used anymore. It'll even give you pop-ups saying, like, the word variant is not supported anymore. Please use object, things like that. So it's It's pretty smooth, honestly. There's a lot of carryover. VB.NET was honestly made for people who are just more comfortable with that syntax, but still want to be in .NET. And then .NET, of course, it was basically just created as a response to Java. That's why C# and Java are so similar. So if you already know Java, then you'll have a really easy time getting into C#. Anyway, if I click Convert Code, you can take a look. You can see, comments are a little bit different. You have your semicolons on the end of lines. You have some curly brackets here or there, but still readable, nothing wildly different. So yeah, I think I've made my point on VBA. So when would you make an exception where I'd say don't dive into VBA? Well, basically, if you already have a background in computer science and development and you know .NET like the back of your hand, you're probably going to be able to read VBA code anyway, so you don't need to, I'm sure you already know that. You don't need to go out of your way to learn a lot of extra VBA. And then likewise with C++, I think the only time I've seen it used is when somebody just knows C++ really well, they're really comfortable with it, or maybe they're trying to integrate this new SolidWorks API code with an existing C++ program. Okay, maybe that would be an instance where it'd be useful. So yeah, VBA macros, when do you use them in production? Again, if you had like an entire engineering department, maybe 10 or more people, and this was going to be spread across different regions, it wasn't going to be isolated to just your office or even your cubicle, I would definitely hesitate to use a VBA macro. You probably want to use something more robust. But if it's something just you and a colleague are going to use, then to speed up a few routines here or there during the day, no big deal. But again, something commercial, you definitely don't want to use VBA. VSTA I already talked about. I don't use those. Never found them to be very stable. I find them too complicated to set up. I find it easier to just create a standalone anyway. Again, VSTA is basically macros you can write in .NET. But I already showed you how you can create a standalone, just use that activator.create instance, and you're good to go. So if you want everything boiled down, and this reflects what I do professionally, what we do professionally, this is really the three types of programs we're doing 99% of the time. We're either doing a VBA macro, a .NET add-in, or a .NET standalone. And even then, like I said, I will argue with a customer if they want a VBA macro. They have to basically tell me, write it in VBA or you're not getting the job, and then I'll be like, all right, fine. But I would much rather write them a .NET add-in. So most of the time, 99% of the time, we're writing .NET add-ins and .NET standalones for our customers. And then
what are the antivirus implications of the three?
The antivirus.
Right. Well, the antivirus won't pick up the DLL, right?
It can. It absolutely can interfere with your software, but there's different protocols you can go through. There's signing. Your IT department's going to have its own policies. I haven't had a lot of customers that come back to me and say, hey, this is unusable because of our IT policies. Usually their IT department can solve the issue. But I will say that in order to have an add-in registered, and by the way, on Wednesday I'm doing a class on how to create an add-in from scratch if you want to see how that works. Even though it's full, they'll generally still let you sit in the back and just watch. But we're going to really look at add-ins under the hood and how registration works. And one of the things I'll point out is that you need to have administrative privileges in order to register it, because you're messing with the registry. So again, if you have huge IT problems at your company, it's a nightmare to work with IT. Okay, yeah, then add-ins are maybe going to be a little bit more frustrating than they already are.
Something to deploy quickly when you're just a small group, it's probably better to go with the
Yeah, small, simple, don't have to mess with IT, don't have to install it, don't have to do much with administration, don't have to do much as far as upgrading. But again, another thing, we don't have time to talk about version control and source control right now, really. And if you don't know what that is, I don't have time to explain it. But basically, you can't, it's not really that effective to use source control with your VBA macro since it's a binary. You can't track the changes easily. So it's like you'll just rename the macro file version 1 point whatever and increment it and send that out to your users, but that's it. Whereas with .NET, you can create MSI installers, ship those out. It's going to be able to recognize, hey, this is a newer version. It'll overwrite the other version. It'll add it to your programs and features dialog. It's just a much more professional experience. Any other questions?
So you're developing Visual Studio 17. I tried to do it in Visual Studio 19. It's harder to find the templates. Do you or does Cat Sharp have any sort of tutorial on how to set up the SolidWorks templates for Visual Studio 19?
Are you talking about the SDK, the SolidWorks SDK? So actually, that's a great question. I do not use the SDK. The SDK is basically a demo of what an add-in can do. I don't recommend using it to actually create software from. What I would recommend is creating your own template from scratch, which we have tutorials on how to do that. We're going to do it on Wednesday. Also, my friend Artem, sitting right here, he's teaching a class and he's going to show you how to use one of his frameworks. I think that's one of the last sessions on Wednesday, right? But you would agree, if you're going to create an add-in, start from scratch, start simple rather than working from the SDK. Yeah. So yeah, you can work from the SDK, but what you end up doing is paring down all of this extra code to what you actually need and then working off of it, rather than just starting with the bare minimum you needed anyway and working off that. That's the difference. As far as just the actual problem of why that won't install, I don't know. You'd have to email API tech support. That would be in their realm.
I mean, also just knowing what packages to install with Visual Studio can be just literally the setup of Visual Studio, just someone who's not a developer, can be quite intimidating.
So I'll say this. I actually use professionally the community edition. That is just the free version. Anyone can get it. Okay, there's some exceptions. If your company makes like over $1 million a year, they're expected to buy the full version. But if you're doing this basically experimentally, obviously you don't have to reveal anything to Microsoft, but if this is just your own personal project, just for you or 1 or 2 people, just use the community edition. You can download it for free. It's pretty easy to install. I haven't ever had any problems installing it. The higher versions, though, that get into whatever the collaboration tools and whatnot, they might have more packages and be more difficult to manage. But yeah, Visual Studio is not hard to get your hands on. I should have mentioned that. It's nothing stopping you really from using Visual Studio. Anyway, please fill out the survey, give me some feedback. I really enjoyed doing this. Hope it was useful to you, and thanks for coming. You're welcome to stop by my booth afterward.